I'm going to talk about enabling agentic operations at scale. I want to focus on some of the technical enablers that we are literally putting in place right now in Lloyd's and that we are going live with in production in the next couple of weeks. But why on earth would you listen to me? Probably shouldn't, genuinely probably shouldn't. I have no certifications whatsoever in this space. However, I find you learn stuff as you go along, right? And you pick up what you need. So, a bit of background from me. I'm currently principal engineer for Hive Lab, which I'll come on to talk to in a second, which is providing an agentic platform for colleague operations across Lloyd's banking group, but specifically looking at consumer relationships, which is every time you go and speak to branch or you ring up and speak to personal banking, it's these sort of folks. Before that, I ran a team that implemented Merlin, which was Lloyd's Banking Group's first Gen AI augmented platform for complaints with summarization, classification, indexing. So we learnt a lot there. And then before that, I ran the team that was responsible for the bank's, the application is affectionately known as CBAS, Chatbot as a Service, nothing to do with fish. And that basically powered the virtual assistants for the bank, customer-facing virtual assistants. So conversational AI and NLP, where I've been in for the last few years. Scaling challenge. So building an AI agent, one AI agent, pretty straightforward, right? The stack we're using at Lloyd's predominantly is Google. So we're using Google ADK as an open source framework for building agents. It's easy, like relatively speaking, to build an AI agent, to deploy it, to run it. There's very, very little that you need to know about that. But the risk is if you're trying to do this within an organization at scale, you can't do it siloed because you end up in a position whereby none of it's reusable, it's duplicated, it's not even common in the way that it's doing it, and simple things like you can't share state across the various agents that get built. So how are we solving this? So I mentioned Hive Lab. So Hive, I think I can say this, I'll take it out of the recording if not. Hive is an application that we are building that does exactly that. So the idea is that we look after colleague-facing operations, we build agentic solutions, single-agent workflows, multi-agent workflows in a reusable manner. We build the tooling, we build the agents, and we provide the full stack that allows you to invoke those agents, whether they are single-agent or multi-agent workflows. And they are designed for both colleagues to interact with and then workflow systems, so effectively to call via APIs. So a lot of what I'm going to talk about, well, all of what I'm talking about, is what we are doing now to not hit that prototype silo on the left-hand side and instead try and think of this at scale. So we are looking at, I've put 5 pillars. You could build a coliseum with some of the topics that are sort of unique to come into this. 5 pillars, 2 horizontals. Registration and visibility is all about how do we make sure that everybody knows what exists and it's visible and you can understand how it works and you can search it in a registry, you can reuse it. How do we orchestrate? Both how do we orchestrate the agent to begin with in a safe manner, but then how do we enable agents to orchestrate themselves depending on the dynamic needs? Tooling, how do we do that at an organisation at scale? Lloyd has been around for 250 years. I was saying to somebody earlier, I genuinely reckon some of the systems we have got are 250 years old. So how do you even interact with those and that data? Context and memory, how do we do that? How do we ground the agents? How do we do that in a consistent manner? How do we make sure that they have shared memory, whether it's episodic or semantic? And how do we evaluate, which I'm not going to touch on a massive amount. And then observability, FinOps, how do we do that at scale? I am not at all going to talk about security and authentication, because that in itself would take hours, and I am not the person for that. So, pillar 1, registration and visibility. How do we ensure we have an easy to access real-time view of agents and tools that we deployed? So this is genuinely what we are doing now. The lens that we are coming at it from is not as a governance aid, but as an aid for, if I'm an AI agent developer and Joe Bloggs is over there, how do I make sure that he knows or she knows what exists, how it works, can they use it before building their own, deploying their own, and we end up in a quagmire of similar solutions. The solution that we effectively have for registration is any AI agent that we build, regardless of the framework, any, I've called them tooling service, but MCP servers, anything that we build there, we have a common mechanism that we have to register them. And it's really simple software engineering, right? So put endpoint for those agents and those tooling services to hit. So as soon as they are deployed into GKE or Agent Engine or wherever we're putting them, they call that endpoint, they register themselves. We calculate a version hash, so we know exactly that version of that particular agent or tooling service, We can validate whether it's the same version as a previous version, so if we're scaling, we don't update things. But where it is different, we capture that snapshot in the database. That then allows us to put that into a registry and marketplace, so then we have an easy ability to surface all of the agents, all of the tooling services that we build. Nice simple UI. I couldn't show you it, mainly because this is not on my work laptop. I probably shouldn't show you what's on my work laptop anyway, but you can believe me that that's true. And it is about automating that discovery as well. So if I can see all of the agents that exist, and I understand the description, the URL where they're hosted, the tools they have, all of the metadata, then an agent can see that as well. So this is like a grounding simple principle of how do we enable humans to see this, but also how do we enable agents to see this. Orchestration. So I'm going to split this into two. The first is application orchestration. And again, we're not doing anything fancy, right? So what I've found most about building Hive and the agents is it's a software engineering mindset as much as anything else. There's less about, sorry to the crowd, there's less about data science and machine learning to building AI agents than building fine-trained models to do X, Y, Z, right? So it's like a paradigm shift of where we were with traditional software engineering to where we went to with machine learning to sort of some happy medium ground in the middle whereby to succeed in this, you need to know software engineering, you need to know DevOps, you need to have an understanding of data science and MLOps, but you don't really need to be an expert in any one of those areas. You need to be able to sort of blend those skills together. So application orchestration, standard stuff. So any client, whether it's a user, a colleague, an application, we're using Apogee as a proxy, server-side events so that we can do streaming, and then it's a Nest.js microservice that sits behind this that does the orchestration. And we're doing this so that we can control the invocation of these agents, that we can run some input guardrails. We're not duplicating that code. We could write that into the agents, and every agent has their own input guardrails, but it's duplicated code. There's no need to do that. It's deterministic. We strip that away from anything that the agent needs to do. Ta-da! This is pretty much the service file. I changed a couple of the names. I stripped some bits out. And again, there's nothing fancy here, right? So any single message that we send to an agent, any of the agents that we deploy, goes through exactly the same process before it hits the agent. And it's like instantaneous, right? Milliseconds. So we sanitize the message. We do script and HTML injection checks and strip it out and sanitize it. We do prompt injection checks using Model Armor, so we validate that the input is safe. We retrieve the latest version, URL and the version hash, I'll come on to it in a second, and then we create a session if one doesn't exist. This supports then that single invocation where there is no session, multiple invocations when it's a returning user, and then hit the agent. And then the big thing that we are doing around then is linking, I'll come to it in a sec, but linking an agent to the events. So if you have version 1 of an agent and you've deployed that version 1, that's got a model, that's got prompts, that's got tools, it's got one particular configuration. You hit that agent 1, 2, 3, 4 times. If I deploy version 2 of that agent, something's changed, right? But the session still allows me to talk to version 2 of that agent. So turns 4, 5, 6, 7 could be with version 2 of the agent. If something goes wrong, how do I attribute the events and what went wrong to a particular agent version? And then I'll come on to like reversibility, but that's effectively how we do that. So we record every event that the agent completes against the version hash of that agent so that we have that ability to look at exactly what version of the agent or tooling service we had at that point in time. Yeah, nothing else there. And then more dynamic orchestration. So we hit the agent, right? So we've hit an agent. This allows you to connect to an agent. How you build that agent, how you configure that agent, whether it's a single agent, whether it's multiple agents on a graph or sub-agents or remote agents, is this. There's 2 mechanisms that we're supporting at the moment. Really simple. Like if you build an agent, you define the agents, the sub-agents that agent can always use. It'll self-route, self-plan based on what is available. So classify, retrieve that workflow, plan. I know that I've got access to agents 2, 3, 4, 5. I'm going to work out that based on this context, I'm going to use agents 3, then 2, then 4. Not going to bother with 5. Which works, but there are scaling problems with that. So again, we're talking about scale. So if I follow that method for everything, anytime I build a new agent, I have to work out whether that agent should be connected to from another agent, and then I end up in sort of like a regression, endless loop of having to update all those agents that might or should talk to the new agent. Like, it's not sustainable. So what we're looking at then is that more dynamic ability. We've got everything in the registry. We know all the agents that exist. We know where they are. It's like Big Brother at all times. We are watching them. But we can query that, right? So we can cache that, we can query that. We always know what's available, what's not available. And the agent can then dynamically work out, there's 50 agents on the network. What should I do? Which ones could I use? Which ones shall I use? And plan. And then there's guardrails and controls we'll put around. Don't use those agents. Use these ones instead. But the idea being is that that's scalable. Comes with some risks. But these are patterns that we're trying to explore at the moment. There is no right answer to which pattern is the right thing to follow. So very much about experimentation at the moment. But these are sort of two orchestration patterns that we're looking at. Tooling. I mentioned the age of some of the systems we have. And again, I'll check whether I can say this. We have a lot of systems, like ridiculous. If you took a mortgage out in 1980, the chances are that mortgage and the information is still sat on the same system that existed in 1980 when you took that out. Modernisation, digitisation, like starts and stops. So we get so far and then go, actually, no, we'll stick with this over here. So we end up with more than 500, probably thousands of applications that exist across Lloyd's. How do you find the right one to connect to? How do you understand all of the APIs that exist, don't exist? We are not connecting to all of these systems. We follow a data model, like an organizational data model, 3 levels. Level 1 is things like party, which could be a party at Lloyd's, or probably any financial organization. It could be a customer, it could be an organization, it could be a third party, a power of attorney. They are a party, they're a person related or an entity related entity. We have then products and portfolio, we have events. So there's loads of these sorts of data models. And we're trying to align strategically to that data classification rather than the systems itself. So 2 examples, customer data, customer events. Could have 3 systems. How do we build those tools? Well, we essentially make them relational and domain relational to that data object. So customer MCP might contain get profile as a tool. That is not linked to a system. It's not linked to a particular type of data. We don't end up with like loads of really granular tools that just make it impossible for an agent to work out what it needs to do. And then we use whatever APIs, data products, direct database connections, files, whatever we need to make up that tool. And the idea there, it's like a facade against standard software engineering, right? So it's like a facade, like a proxy. If we decide that API 1, 2, 3 are fated, we can swap them out for whatever the strategic solution is. And we leave the tool alone, we leave the domain alone. The agent should still be able to work at scale without having to be affected by that change. So that's just an example. And then context and memory. So these are more experimental, I would say, in terms of what we're trying to do. You tell me whether any of this is the right solution. But one of the things we find is we are an organisation of 65,000 people. About 50% of that is probably operational staff. So whether that is telephony, whether that is branch, whether it's back office people, whether it's planning, 50% of the organisation is operational people that have their processes, their knowledge articles, and they're written by different people all the time. They're at different levels. Like, how could you give that to a set of agents as a repository of knowledge that they should ground themselves on when it's full of repetition or full of contradiction? Like, you can't. We don't. So instead, it's more about how do we make the knowledge that we have safe and appropriate for agents. So we're doing this via a mirror. So effectively, we have our colleague-facing knowledge store. We have an event hook effectively on everything that goes on in there. So whereby we see a document change or a knowledge article change, we're able to ingest that. We're able to then use Gemini effectively to rewrite that, to question and answers, to embed that, to put it into a vector store, to make that easier for agents to connect to. There's approval loops in there as well, so that we make sure that actually just because somebody updated something, we don't really know if that's going to be fit for purpose for agents. So there is an approval loop. And then there are multi-stage automated tests in there to again validate that if I ask question 1, I should expect answer 1, sort of stuff that's all baked into that. But the idea is it allows us to, at scale, ground the agents without having to continuously update the agents. And then it comes to observability and evaluations as to how do we make sure that these changes that occur don't break the entire stack. And then context and memory. I'm nearly there, honestly. So providing memory. We're using, so I mentioned our stack. We are a mixture of Google and open source. Google and open source. So we build agents using Google ADK. We deploy those agents. At the moment, I'm deploying them into GKE. We're putting them in Agent Engine in Vertex, so Vertex AI Agent Engine. We're going to use chat sessions that comes with Vertex AI chat sessions, so we're not managing that in Cloud SQL. But that manages that working memory. What am I doing right now? What have I said right now? What's Joe Bloggs said to me right now? It's that working memory. How do we then get insights and enable insights episodically around what happened, when did it happen, and then semantically around what facts and truths exist. Now, there are Google products that exist for this, like Memory Bank, but it's a black box, which doesn't really work for an organization that needs to be auditable and visible around every decision that's ever made. If Gemini decides, Gemini's a bad example because we are using Gemini. If a language model decides that this is a fact, is it really a fact? How do you know that what the model thinks is a fact is actually a fact, and is that reliable? So Google pitch Memory Bank as, gives you chat transcript, we'll run the language model over it, we'll work out what's fact, don't worry about that, and we'll store that. No, thank you. So what we're trying to do is that, but more transparent box. So the idea is that all the chat sessions exist, they're persisted, we have either triggers at the end of that session or periodic triggers job to pull that out, run that through a language model. The idea then is that we are able to then hold that episodic memory, that semantic memory. We're able to pull that back into the agents on the next sessions with the same user, and it creates that personalization. So if I know that the last time I spoke to Joe Bloggs and we said XYZ, I can pull on that. That's like your memory, right? And this is how we're trying to achieve that within AI agents and trying to do it at scale rather than siloed to one particular agent deployment. And it's proving painful, but it is interesting. Evaluations, I'm not going to touch too much on, but essentially we are trying to run offline and online evaluations. There's a range of things we're doing offline. So we're using Ragas, we're using DeepEval. Lloyd has a custom framework as well called Pegasus. I'll check that one as well. But essentially has a load of stuff baked into it. So we are able to run offline evaluations on, and I'm going to check my notes, on agentic metrics, so like response alignment, tool correctness, trajectory, efficiency, conversational metrics with FinBench, conversational experience index checks, topic shift, did the agent manage to be able to continuously hold 2 topics in mind and solve both of them, turn efficiency. All this is then run offline, gives us the confidence that the agent is going to do what it should do in production. But then, and this is probably the difference from like traditional software engineering, more into the data science, machine learning, it's that live monitoring, and actually it's proactive rather than reactive. So we look at runtime metrics, we look at running some of the same evaluations using golden data sets in production so that we know that we're using foundation models predominantly, but the idea being is we should be able to use any model. So we should be able to use a trained model for the agents, of which there could be model drift. So again, all of this live monitoring gives us the ability to check versus these golden sets of data, are we still performing in the way that we expected when we went live? It also provides a bit of a regression set when we do model changes as well. And then reversibility, observability, FinOps. It's just standard stuff. So like open telemetry, everything is being captured. Like we are capturing everything about everything that the agents do, the servers do, the tools do. All of that is being collected by the OTel collector that we have running in the stack, stored in Cloud SQL. It's still an experimentation phase, but we're looking at Langfuse as an open source solution and to being able to observe all these traces. But we can run evaluations. There's loads of stuff that Langfuse gives us that we are able to deploy and run ourselves, trying not to get vendor lock-in. We could lose Langsmith, but we end up then stuck a little bit. We use Dynatrace as well organisationally, so there's things that Dynatrace could do that we might look to explore. And then I mentioned it before, but like reversibility. So this is critical. If I, as a colleague, do something right now in the organisation, we do outcome testing. None of this should be a surprise, right? We do outcome testing. We should make sure that, yeah, you did the right things. You said the right thing. We don't need to worry about it. We need to do exactly the same things for agents. Like, nothing changes. We still have to outcome test them. We might automate that outcome testing, but we still need to quality check them. It still has to be done so that we don't open ourselves up for financial rectification further down the line. So this is like what I said before about, this is why we're storing all the versions and all the version hashes. This is how we create that end-to-end trace of everything that was done by a particular version of a particular asset at a particular point in time. We can reverse all that config out. We can see the data points of the customer that we were interacting with. We could see what we changed. This is how we create all of that audit trail. It is critical for us being able to go live. We can't go live without this sort of stuff. And then circuit breakers, environmental impacts. Like, one of the interesting things that we're trying to do at the moment is around measuring the cost of an AI agent. And it's tricky because you've got your standard infrastructure costs. If you're deploying it into Cloud Run, GKE, you've got your standard sort of runtime costs. That's easy to measure. You've got your token usage and attributed costs then from the language model. But you would never, well, okay. We would never go to like the nth degree of every single pod and the cost of that particular pod in the stack, right? And we roll it up a little bit higher than that. But for an agent, we need to do that. We need to get as granular as possible on how much is this particular tool call costing, and how much is this particular language model costing on this particular agent, and how many events are we triggering, all that sort of stuff. And then the environmental impact on all of that. So one of the things we're doing, again, we're using sort of Prometheus, it's standard stuff. We're just using particular gauges or setting particular gauges around environmental metrics, and we're storing all of that. So we have the ability then to show the particular cost of an agent, the cost of a user, particular cost of a user on an agent, whatever sort of lens you want to cut on it, again, which is really, really useful. And that is where I will stop. So thank you.
Thank you.